A material degrades to 99.8% of its previous year's strength. How strong will the material be compared to its original strength after 100 years? How many years will it take for the material to be at 50% of its original strength? Okay. So if the material degrades to, so let's start off at 100%. The next year, year 1, this is year 0, so year 1, it will be at 99.8%. At year 2, it will be 99.8% of 99.8%. So 99.8 times 99.8. Oops, well, okay, so 0.998 times 0.998. That's a little better. And that's going to be at 99.6%. Okay, and it keeps on going that way. This is a geometric series, but let's just confirm that, okay? So k is equal to, if we think it's an arithmetic series, we can check here. A to the n plus 1 minus a to the n is going to be equal to 99.6 minus 99.8, and that's going to be equal to negative 0.2. And 90... Oh, there it is. Sorry. I was like, whoa, that's going to be the same. But this is actually 99.6004. Okay, let's be very specific about this. So that minus 90.998 will give me 0.1996. Okay, and then 99.8 minus 100 will give me 0.2, negative 0.2. Okay, so they are different. So they're not an arithmetic series. Not an arithmetic series. Let's check a geometric. R is equal to a to the n plus 1 divided by a to the n. And for here, we go, it's going to be 99.6004 divided by 99.8. And 99.8 divided by 100. Well, that's going to be 0.998. And this one will also be 0.998. Interesting fact, even if you put this into percentage or into decimal form, you'll still get the correct ratio. It will not have units to it. This is the correct ratio. So don't worry about the units of having decimal of having in percentage form or in just regular number form. So it will always give you the correct ratio. So that is the ratio, 0.998. So yes, it is a geometric series. Geometric series. Okay, so now we're looking for the strength after 100 years. Well, we know that a to the n is equal to a to the 1 times r to the n minus 1 for a geometric series. So we know A1. A1 is going to be this one, A1, for the first year, because it's asking after 100 years. So yeah, first year is going to be this percentage. After 100 years. Yes. Yeah. And ratio we know, and n will be 100. Okay. So a to the 100 is going to be equal to a to the 1, which was 99.8, times 0.998, and the ratio, and n is equal to 100 minus 1. So 0.998 to the power of 99 times 99.8 is going to be equal to 81.9%. Okay, that's after 100 years. How many years will it take for the material to be at 50% of its original strength? Okay, so we're going to still use the same equation. It's going to be a to the n is equal to a to the 1 times r to the n minus 1. But now we're looking for n. Interesting. Okay, so we have to divide by a1, and then we can take the ln of it, or the log. That's how you get outside here, remember? A to the n divided by a to the 1 is equal to r to the n minus 1. How do you get that guy down? How do you get him down? The only way to get him down is to take the natural log or the log base 10. That is the purpose of logs. It takes it down. So when you take the log there, this one will just stay log of a to the n over a to the 1. And this is going to be equal to n minus 1 times ln of r. That's the purpose of ln. That's why you use lns. It brings it down. And now we can just solve this. So now we're going to divide by r and then plus 1. So n will equal to plus 1. So it's going to be ln of a to the n all over a to the 1 divided by ln of r plus 1. Let's plug in some numbers. So a to the n was 50 because a to the 1 was 99.8. And a to the n is 50%. Okay, so ln of 50 divided by 99.8 all over ln of 0.998, that's the ratio, we determined the ratio initially, plus 1. Ln of 50 divided by 99.8 equals ln of answer equals divided by ln, bracket open, of 0.998, bracket closed, equals plus 1 is 346 years. Always a good thing to do is maybe just check the previous answer, because we know a to the n, it was 89.9. So let's just check that. So 81.9 divided by 99.8 equals ln of answer equals divided by ln of ratio, which was 0.998, plus 1. And look at that. We're at 99.7 years. And that's probably just to do with some rounding here.